Good day everyone, my name is Navendran and I'm going to give an introduction about tire. Tire wear particles TWP are microscopic particles generated during tire road interaction due to friction, abrasion and mechanical wear. These particles are a significant source of microplastic pollution, posing environmental and health risks. Understanding TWP is crucial for improving tire designs and reducing environmental impact and enhancing road safety. This review examines the formation mechanism, measurement techniques, physical and chemical properties, and key factors influencing TWP generation. Now we are going to discuss about the general topic. General 1. Comprehensive review of tire wear particles, formation, measurements, properties, and influencing factors. This is of the find from the journals and the first find of the methodologies from the journals. The first point is gravimetric analysis. This method involves collecting and weighing TWP from controlled test or road environmental to determine the total mass of particles generated during the tire wear. The purpose of this point is quantify TWP production under varying conditions like speed, load, and road surface. The next point is microscopy and spectroscopy techniques. Tools like scanning, electron microscopy, and energy diffraction X-ray spectroscopy are used to analyze the size, morphology, and chemical composition of TWP. The purpose is to provide detailed insight into the physical and chemical characteristics of TWP. The third point is road simulation experiments. Laboratory-based road simulators replicate real-world driving conditions, example acceleration, braking, cornering, to study the effect of variables like road texture, speed, tire metals on TWP generation. The purpose is to help isolate specific factors contributing to TWP formation in a controlled environment. Next is the result from the journal. The first point is impact of driving speed and load. Higher driving speed and heavier vehicle loads significantly increase TWP generation due to greater frictional force and wear rates. Next point is chemical composition of TWP. TWP consists primarily of synthetic rubber polymers, metals such as zinc, iron, and hydrocarbons with varying composition influenced by tire materials and road conditions. The third point is environmental accumulation. The findings are urban areas with high traffic density experience with the greatest accumulation of TWP, contributing to air and water pollution, particularly in regions with inadequate drainage system. And that's all from me. Thank you.
Okay, now I'll be explaining about the Journal 2, which is Advancing Vehicle Tires, Innovation, Performance, and Sustainability in Modern Mobility. So the methodology is material composition and design. Tire manufacturing involves a combination of materials engineered for durability, flexibility, and performance. Natural and synthetic rubber serve as the primary constituents, providing elasticity and wear resistance, while steel belts and polyester cords enhance structural integrity and prevent deformation under stress. Silica and carbon black are used as fillers to improve wear resistance, traction, and rolling resistance. Advances in material science have led to the development of specialized compounds tailored to specific applications, such as winter tires, racing tires, and all-terrain tires. Okay, the second methodology is tire dynamic and performance. The performance of a tire is evaluated based on several key parameters, including traction, rolling resistance, durability, and noise and comfort. Traction is influenced by tread patterns and compound composition, ensuring grip on various surfaces. Rolling resistance, a measure of energy loss, directly impacts fuel efficiency, while durability refers to resistance to wear. punctures, and deformation. Noise and comfort are optimized through design features aimed at reducing road noise and enhancing ride quality. Modern tire testing incorporates computer simulations, track tests, and laboratory analysis to ensure optimal performance across these parameters. Okay, and the next one is innovation in tire technology. Recent advancements have transformed the tire industry, equipped with sensors, monitor pressure, temperature, and wear in real time, improving safety and maintenance. Sustainable materials such as renewable and recycled options are increasingly used to reduce environmental impact. Airless tires eliminate the risk of blowouts and reduce maintenance requirements, while 3D printing allows for custom manufacturing, reducing waste and production costs. Okay, the next one is the results. So the first one is increase in operational efficiency. A recent study reveals that innovation in material composition have led to enhanced durability and performance of tires. The integration of silica and carbon black has improved wear resistance and traction by 25%, especially on wet surfaces. New rubber compounds tailored for specific applications, such as winter and racing tires, have demonstrated a 30% increase in operational efficiency under extreme conditions. And the next one is optimize extended drives. Testing across key performance metrics shows that modern tires achieve a 20% improvement in rolling resistance, translating to higher fuel efficiency and reduced carbon emissions. Enhanced brake patterns and optimized compound formulations have increased traction by 15% on varied terrains. Noise reduction designs have resulted in a 10 decibel decrease in road noise, improving passenger comfort during extended drive. Okay, and the next one is the awareness of traction. Smart tire implementations have reduced tire failure rates by 20% as real-time monitoring system alert drivers to potential issues before they escalate. Sustainable material adoption has lowered the manufacturing carbon footprint by 15%, while airless tire prototypes report a 30% increase in lifespan and resistance to deformation. Additionally, 3D printed specifically tires have shown a 40% reduction in production lead time with experimental trials confirming performance parity with traditional manufacturing methods. Thank you.
We explain the methodology of the Journal 3, Smart Tire Technology for Enhanced Performance and Safety. Okay. Development development of smart tire system. The authors slightly describe the integration of sensor, actuator or advanced material tires to create smart capabilities such as real-time monitoring of tire pressure, wear, and traction and condition. Laboratory testing to evaluate the effectiveness of the smart tire technology. Control lab tests could have been conducted to stimulate different conditions like wet, dry, and icy roads, and measure performance parameters like braking distance, stability, and overall safety. Okay, the third one is a field test. Field test in real world testing will also be critical. The study may have involved testing the smart tire on vehicles under actual driving condition to assess their practical performance, durability, and reliability. Okay, and lastly, data analysis. Data analysis probably use statistical or machine learning techniques to analyze the data collected from both lab and field tests, comparing the performance of smart tires with traditional tires to quantify improvements in safety, efficiency, and overall vehicle handling. Okay, that's all. And for the result of enhanced performance, the study likely showed that smart tires vehicle handling, stability, and responsive. For example, smart tire could adjust their properties in real time, such as modifying the tire pressure and monitoring tire wear, leading to a better traction and more predictable behavior under the various conditions when driving. Okay. The second one is it can improve safety, such as the integration of sensor and monitoring system that could have contribute to a reduction in accident or tire failures. Smart tire technology can potentially alert driver to issues like under inflation or where they became dangerous, enhancing the overall safety. Okay, and lastly, efficiency gains. The result could also have demonstrate that smart tires contribute to better fuel efficiency or lower energy consumption. Thanks to optimal tire pressure and performance, reducing rolling resistance and improving the overall vehicle economy. Okay, that's all from me. Thank you.
Hello, Assalamualaikum. My name is Muhammad IMRAN bin Muhammad SHIRKHAN, and I will explain to you guys about the methodology of Journal 4, the road to sustainable tire materials, current state of the art and future perspectives. Firstly, what includes in this journal is comparative analysis, comparison of traditional tire materials such as synthetic rubber, carbon black, with sustainable alternatives, evaluation of environmental impact, performance metrics, and cost effectiveness. The second thing that includes in this journal is case studies, examination of specific examples where bio-based or recycled materials have been successfully implemented in tire manufacturing. It also discusses about the challenges encountered during material integration and solutions applied. And lastly, the methodology of this journal is expert opinions and future perspectives. The insights gathered from interviews or collaborations with researchers, manufacturers, and policymakers. Emphasis on identifying technological advancements and regulatory frameworks necessary for widespread adoption. The results that can be gained from this journal, firstly, the advancement in sustainable materials, identification of promising bio-based materials such as natural rubber alternatives, starch, and cellulose-based polymers. Then success in incorporating recycled tire components like devulcanized rubber and fillers into new tires. Second thing is the performance insight. Current bio-based and recycled materials exhibit acceptable performance in durability and rolling resistance, but lag behind traditional materials in certain areas like grip under extreme conditions. Other than that, the innovations in material blending and treatment are closing the performance gap. And the last result that can be gained from this journal was the environmental benefits. Reduction in carbon emissions through the use of renewable and recycled materials. Mitigation of waste through circular economy practices like recycling and reuse of end-of-life tires. That's all from me. Thank you.
As for the conclusion, vehicle tires are not just functional components but pivotal contributors to automotive performance, safety, and sustainability. The industry's advancements in material compositions, performance optimization, and innovative technologies such as airless and smart tires signify a transformative era. Moreover, the focus on sustainability through the adoption of renewable materials and circular practices highlights the industry's commitment to environmental stewardships. As the landscape evolves, continuous innovation and collaboration will ensure that tire meet the dynamic demands of modern mobility while contributing to a greener future.